Hello friends, welcome back my YouTube channel. I am Maths. In this video I will discuss the topic which is related to the vector calculus. So the topic to be covered with the practice problems, that is basically gradient, okay, and then we will discuss about divergence, then curl, line integrals, the examples of the line integrals, for example work and the flux over the simple closed curve, that we will discuss. And then that next topic will be discussed, which is Green's theorem and the surface integral, and related to this Gauss divergence theorem, Stokes theorem. So this topic, this particular video is for engineering mathematics and who is in BSc mathematics, so they can refer this video. In this video I will discuss complete vector calculus. So this will be a one short video for vector integral calculus or vector calculus, okay, in which I will discuss these three important theorem, that is basically Green's theorem, Gauss divergence theorem, and Stokes curl theorem. So let's begin with the topic of the very basic, that is the gradient. And before going to the gradient, we will first see what is the gradient operator, what is the meaning of this operator, and what is the physical significance, and we will solve a lot of problems. And my point of view is that when you will solve a lot of problems, that will help you out to understand the varieties of the question, to understand the flow of the question, how the question will be asked in your exam. Let's begin with the gradient operator. So this gradient operator is basically the differential operator, okay. This is called vector differential operator. So what it does and why we are using this. So basically, if you have a function of one variable, let's say y is equals to f of x, to find out the slope for this particular curve, then we are using simply dy by dx, okay. And the thing is, here we are only finding the slope in the magnitude form. We are not going to use any of the direction, because there is no direction given. Let's say this is in the positive x direction, positive y direction. There is no direction. We are not bothering about the directions. But the problem in the vector calculus, whenever we are dealing with the vectors, there is an important factor is that called magnitude as well as direction. So for denoting the direction, to identify the direction, and of course that will be not a simple function of one variable, that will be gonna like simple like a function of several variable. So in the case of function of several variables, z is equals to, let's say, f of x comma y, or simply let's say w is equals to f of x comma y comma z, it means it will be simple function of several variables. So in that case we are not going to use this ordinary derivative. So that's why we are using the partial derivative, and partial derivative will represents the rate of change of a particular direction. And to denote the direction, of course in vector calculus we are using I cap, j cap, and k cap. So this gradient operator is basically a operator. So for example, to finding dy by dx, so here d by dx is applying to y, it means this d by dx is derivative operator, and this is the notation. So here this nebula is a symbol, and we'll call it as del basically. So this is del, or we can say it says this name of the symbol is the nebula. So when we will apply this nebula, then this nebula is nothing but partial derivative in each direction, x, y, and z, and this is the formula. We will see the questions, how it will how it will be applied to the question, and how can we solve the question. We'll see the examples, okay. So the explanation about this is this this symbol is called as Hamiltonian operator, and nebula, or you can say also the Dale and gradient grid operator, okay. It is neither a vector nor a scalar. Whether the thing is that it has I cap, j cap, k cap associated with this, but still it is not a vector quantity. It is just an operator, okay. It's not the quantity, it's not a physical quantity, so we can't measure it as a vector or a scalar quantity. It acts like a scalar, it acts on the scalar and vector function to produce the gradient called divergence and the curl. When I will apply this gradient operator to a scalar, that will be the divergence. If I will apply to a vector quantity, when I will apply this gradient operator to a scalar, that will be the gradient simple. If I will apply to the vector quantity, that will be divergence, and if I will apply with the cross product, then that will be curl, okay. One by one we will discuss, don't worry about this. Now first of all, gradient of scalar function. So before going to that, next I will explain you what is the scalar function. So scalar function I will denote with the phi. So what do you mean by the scalar function? This is called scalar function. So this scalar function means that okay, So this scalar function means there is no direction associated with this. So let's say f of x comma y comma z is a scalar function. There is no direction of this. Okay, so when I will apply the gradient to the, it means that like delta, if I will apply delta to this phi, then this formula, the I cap dou phi by dou x, okay, dou phi by dou y and dou phi by dou z. So it is basically the partial derivative with respect to x, y, z of phi in the direction of I, j and k. So this is the formula. Okay, and it also denoted by the grade of phi. I can also write like this. This is the grade of phi, which is like implying this. Okay, so the geometrical meaning is that phi is here. The thing is that this phi, this is a scalar quantity. Okay, when I will apply this gradient to this phi, now it is a vector quantity. Now it is a vector. Because of that, in del operator there is a direction, that is ijk, and this is very very important. Okay, it points in the direction of the maximum rate of change of the increase of the phi, and its magnitude gives the rate of a maximum rate of change at that point. If I will find the magnitude of this, then it will be the maximum rate of change at that particular point. I will see the examples. Okay, don't worry about this. Let's take the example and try to understand. So this phi is basically here called this phi is the scalar valued function. So I want to calculate the gradient of this, find out the gradient. Okay, so here you have phi, and that is basically phi is equals to, so the solution will be like this. So here phi is equals to x square plus y square plus z square. Okay, I'm going to find the gradient of phi. Okay, first of all, what is the gradient? Gradient is basically dou by dou x of I cap plus dou by dou y of j cap and dou by dou z of k cap. Okay, when you will apply this formula to this phi, so it will be something like this. So this is basically dou phi by dou x I cap, dou phi by dou y j cap, and dou phi by dou z k cap. So it means you have to find out the partial derivative of phi with respect to x, y and z. So how we'll find out the partial derivative? So the first partial derivative with respect to x, this is x square plus y square plus z square, then it will be 2x plus 0 plus 0. Similarly, dou phi by dou y, that will be 0 plus 2y plus 0, and dou phi by dou z is going to be 0 plus 0 plus 2z. Okay, now you put the values here. So that is del phi is equals to 2x I cap plus 2y j cap, okay, and then 2z k cap. So the phi, del phi will be nothing but twice of 2 I cap, okay, sorry, x I cap. So it will be x I cap plus y j cap plus z k cap. This is the answer. And one more thing, in vector calculus, usually we are using r vector is called position vector. Okay, this is called position vector. So this position vector we are denoting with x I cap plus y j cap plus z k cap. So from here, this thing I can write down like this. It is or, it's not necessary that every time you write like this. So this is basically the twice of position vector. This you can write in this form. Okay, so now this is how we can find out the gradient. Now come to the next problem. Let's say you have this particular example and you want to calculate the value of the gradient. How will you find out the value in this case? Let's say this is x plus y plus x phi is equals to, okay, x y square and z cube. In this case, again you have to apply this delta operator to this. So del phi is equals to nothing but I cap. Okay, you can write down I cap before or after, no problem. So del dou phi by dou x I cap plus dou phi by dou y j cap and dou phi by dou z k cap. Okay, now here again you have to find out the partial derivatives. So the partial derivative with respect to x. So here when I will differentiate partially with respect to x, that will be y square into z cube. Okay, y square into z cube. Partially differentiating with respect to y. So x as it is, the partial derivative of y square is 2y, and this z cube is as it is. So it will be 2xy z cube. And similarly, the partial derivative of phi with respect to z is basically x as it is, y square as it is, and z cube is basically 3z square. So it is nothing but 3xy square z square. Okay, now you put the values here. I'll put the values back to this formula. So that is basically y square z cube I cap. Okay, then 2xy z cube j cap plus it is basically 3xy square z square k cap. Okay, so this is the answer, but it is saying that you find out the value at this point. Okay, at this point. So this point 1 2 3 is represents this value as x, this value as y, and this value as z. So nothing but you have to put the values at a particular point. Then this is delta phi is equals to, put the values of y is equals to 2. So it is basically 2 square. Okay, and it is 3 cube I cap plus 2 into 1 into 2 into 3 cube j cap plus it is 3 into 1 into the values of 2 square, and that is 3 square. Okay, this is k cap. So this is basically delta phi is equals to 4 into 9, that is 36. Okay, I will write down directly 36 I cap plus this is basically 27 into 4. So this is 4 into 27. Okay, so 4 into 27 j cap plus, so this is basically 4 into 27 j cap, and okay, one more thing I can write directly, it is 108. So it will be 108 j cap, and now here it is 3 into 4, this is 12 into 9 is again I think it is 108. Okay, 12 into 4, 4 into 9, 36 into 3, yeah, 108, again it is 108 k cap. Okay, so now this is basically the rate of change at this particular point. Okay, the gradient at this particular point. Now basically the thing is that, as I mentioned you here, that here this means that it has a maximum, it acts like a scalar and vector function, and basically when you will find out this, its magnitude gives you the maximum rate of change. Okay, so when we will find out the magnitude of this, how can we find out the magnitude? So magnitude is nothing but mod of phi, del phi is basically square root of, so this is 36 square, the coefficient of I square plus coefficient of y means coefficient of j square and the coefficient of k square. When you will solve this, you will get the whatever the answer you will get, that will be the maximum. This is basically called maximum rate of change at this particular point. Okay, this is the physical significance of this. Now let's come to the next question. So let's say I have this question, log of x into y. So how to deal with this question to finding out the del phi? Just it is nothing but you have to find out the derivatives. Okay, so let's say this is phi is equals to log of x into y. Now here no z. Okay, so let's say my del is basically dou by dou x I cap, dou by dou y j cap. So this is in 2D. Okay, if it is in 3D, then dou z by dou by dou z k cap. So now here once I will apply this formula, so del phi is nothing but dou phi by dou x I cap, dou phi by dou y j cap plus dou phi by dou z k cap. The thing is that this will be 0 here because there is no x term. Okay, because this is function of only x and y. So that's why it means this is basically dou phi by dou x. So log of this will be 1 upon x into y, and this will be x will be 1 and into y. So this is basically 1 by x. Okay, so dou phi by dou y is basically 1 upon x into y, and again this will be x, so it will be 1 upon y. Now you put the value, and again dou phi by dou z is equals to 0. Now you put the value, then we will get it like 1 by x I cap, and this is 1 by y j cap. Okay, this is the gradient of this. Okay, now come to the point that is basically find the maximum maximum directional derivative of this. Okay, so how to find out the maximum directional derivative? That is something. Maximum directional derivative means that you have to find out the gradient of phi. Okay, first you have to find out the gradient of phi, then you have to find out the gradient of phi at this point 1 comma 0 comma 2, and then you have to find out the maximum or like the magnitude of 1 0 comma 2 at this point. So this is the particular step. So this is for you, that simply what you have to do, first of all you have to calculate this phi. It means you have to find out the partial derivative of dou phi by dou x I cap plus dou phi by dou y j cap and dou phi by dou z k cap. Okay, for like simply what is your phi here? That is x e to the power y into z. One partial derivative that I will give you, that is dou phi by dou x. So that is going to be basically if it is x, then it will be 1 into e to the power yz as it is. Similarly, when you will find out the partial derivative with respect to y, that will be x as it is, e to the power yz as it is, but the partial derivative of yz will be z only. Okay, and similarly dou phi by dou z is equals to this is basically x as it is, e to the power y z as it is, and the partial derivative of z will be 1, so it will be y. Now you put these values here, then you put the value 1 0 and 2 as x, y and z, and then find out its magnitude. This magnitude is basically, it will give you the maximum of like maximum directional derivative of phi. Okay, so this is how you can solve this question. Now let's come to the next concept, that is called divergence of the vector function. So here what we were doing, we were applying this del operator to phi. Phi was scalar function. Okay, this was the scalar function. Now what will happen if I will apply it to the vector quantity? Okay, so let's begin with this. So let's say I have this del operator and I'm going to apply this with a vector quantity, vector function, and let's say my vector function is like this: f1 I cap, f2 j cap, and f3 k cap. If I'm going to apply to this, then this is basically a dot product. Okay, so it is dou by dou x I cap plus dou by dou y j cap and dou by dou z k cap dot product with f1 I cap plus f2 j cap and f3 k cap. Okay, and one more thing here, I dot I is 1, j dot j is 1, and k dot k is 1 always. Similarly, I dot j is always 0. Okay, if these both are different, then it will be 0. If these both are same, then it will be 1 in the dot product. So here again, so the dot product of this and this will be 1. It means I dot I will be 1, and this f will come here, so you will get this first term. If I will multiply this I with 2, I with f2j, that will be 0. If I will multiply I with f3k cap, that will be 0. Okay, so this is how you can get this formula. And again here the concept is that if it is greater than equals to, if it is greater than of 0, then it behaves like a source, means from here vector quantity will be produced, and if it is less than 0, that will be sink, all the vector quantity will be vanishing at that point. If it is 0, then it means there is no net flow of the vector quantity. Okay, so it is incompressible field. We will see later, and it will be very helpful. Okay, this divergence called the rate of outward flux. Okay, this is the important physical significance of this divergence. Gradient means the slope, divergence means that the rate of outward flow, because it is a vector quantity, it depends on the direction. So that's why we are representing it as a flux and outward flux. And one more important thing, whenever I applied this operator to the phi, this is a scalar quantity. This is a scalar quantity. Okay, this is very important. Earlier it was a vector quantity. Come to the problem. Let's say find out the divergence of r vector, and I explained to you the r vector is the position vector. Okay, this is called position vector, and r vector means basically x I cap plus y j cap plus z k cap. Okay, when I will apply this to this, then the divergence of this basically it's going to be like this. Divergence of r vector is nothing but, okay, so here f1 is x, so dou x by dou x I cap plus dou y by dou y j cap and dou z by dou z k cap, because the formula is this one, dou f1 by dou x, dou f2 by dou y and dou f3 by dou z. Then this dot product called divergence will be something I cap plus j cap and then k cap. This is the divergence of the position vector. Let's come to the next question. Let's say I have this f vector and I want to find out the gradient of this. Okay, so sorry, the divergence, not the gradient, sorry. Let's take the divergence of this. How to find out the divergence? In this case, it is divergence of f, then f is equals to xy square I cap plus 2x square yz j cap minus 3yz square k cap. Okay, this is f1, this is called f2 and this is f3. So what is the divergence? So divergence is basically del dot f, that is dou f1 by x I cap, dou f2 by dou yj cap and dou f3 by dou z k cap. So now your target is to finding out the partial derivative. So partial derivative of f1 with respect to x is going to be y square. Okay, so and again the partial derivative of f2 with respect to y is going to be 2x square, y as it is, sorry, y1 z as it is, and the partial derivative of f3 with respect to z is going to be minus 6y z. Now you apply this to here. When I will apply these values to the point, plug in the values, then simply we'll get the divergence of f is nothing but y square. Okay, wait, I cap will not be there, j cap, k cap will not be there, sorry for that. So because of that it's a scalar quantity, so y square 2x square z minus 6yz. So see here there is no direction, so that's why it is called scalar quantity. Okay, so that's why it's called like divergence. Okay, so curl of a vector field. So now it is basically again this del operator and f vector, but the thing is that now here we are taking the cross product, and cross product means something finding the determinant. So this is something called I cap, j cap, k cap and its determinant. Okay, so dot product means the coefficient of I cap is dou by dou x, coefficient of j cap dou by dou y and the coefficient of k cap dou by dou z. Now put the coefficient of f vector. So the coefficient of f vector is f1, this is f2, this is ft. Now you solve this determinant. Okay, first you take this one minus this one, apply and then solve the derivatives. Okay, so the meaning of curl is basically it is representing the rotational tendency. Okay, if the curl is equals, this is called curl, if the curl is equals to 0, it means there is no rotation. Okay, there is no rotation of that vector field, it is representing the rotational tendency. If curl not equals to 0, it means there is some rotation, but if curl is equals to 0, there is no rotation of the vector field. Let's take the example, find out the curl of the r vector. Again, what do you mean by r vector? That is x I cap plus y j cap plus z k cap. Okay, so in this case we will find out the curl of this vector, that is going to be the I, j and k. Okay, so again every time you have to write down the derivatives with respect to x, y and z. Now here apply the coefficient of coefficient of I is x, this is y and this is z. Now simple, you have to solve this determinant. So put the coefficient I, this is basically dou z by dou y. Okay, first we will take this one, then minus dou y by dou z, then minus of j. Now we will apply this one, so it will be dou z by dou x minus dou x by dou z plus k cap. Now we will remove this and this, so it will be dou y by dou x minus dou x by dou y, and all of we know that this will be going to 0 because it is I cap 0 minus 0 minus j cap 0 minus 0 plus k cap, it is 0 minus 0. So whole will be 0 I cap plus 0 j cap plus 0 k cap. This is called 0 vector. Okay, so there is no rotation of the position vector. Next, come to the point. Here we will find out the different quantities. Okay, first let's say what is your f vector. So your f vector is x square I cap plus 2xy. Okay, so wait, yeah, 2xy j cap and xz square k cap. Now first question is find out the divergence. So del phi, okay, this is going to be something like this: dou f1 by fx, dou x, dou f2 by dou y plus dou f3 by dou z. Finding the partial derivatives. So the partial derivative of x square is 2x, partial derivative of 2x with respect to y will be 2x, and the partial derivative of z with respect to partial derivative of x z square with respect to z is going to be x into 2z. So it will be basically 4x plus 2xz. So this is the answer of the first question. Now let's begin with the next. Let's say this is first one. Now question number 2, find out the curl of this one. So to finding out the curl, you have to write down the formula I cap, j cap and k cap, then the derivative terms dou by dou x, dou by dou y, dou by dou z. Now put the value. F1 is your x square, F2 is 2xy, F3 is xz square. Now solving the determinant is basically I cap. Okay, remove this row and column, so that is basically partial derivative of xz square with, okay, I'm going to write it directly. So when I will apply y with this, so this is going to be 0 minus here this is 2xy and this is z, so there is no z term, then z. Remove this row and this column. So when I will remove this column, so that will be basically like this: partial derivative of xz square, that is going to be z square. Here if I will take this, this will be 0, then again plus k cap. Now remove this row and this column, that will be, okay, 2y, okay, partial derivative of 2xy with respect to x, like this, that is 2y, and if I will take like this, this will be 0, so it is minus of 0. So this will be 0 I cap, okay, minus z square j cap plus 2y k cap. So this is the curl of this. Now it is saying find out the gradient of this derivative, because see, this derivative term is your scalar quantity. This is a scalar quantity. Now let's say this is phi. So phi is equals to 4x plus 2xz. It means now the question is find out the gradient of this divergence. It means basically the gradient of this divergence of phi. So what's the meaning of this? So this is del and phi is your 4x plus 2xz. Now you have to apply the formula dou by dou x. Because of that you are finding the gradient. Okay, then you have to apply the I. So what is the formula for the gradient? Dou by dou x of 4x plus 2xz I cap plus dou by dou y 4x plus 2xz j cap. You have to apply the ijk. Okay, let's be very careful about this. Then dou by dou z of 4x plus 2xz k cap. Now you apply the formula. So that is basically when I will partially differentiate this. Okay, let me take this one from here. Okay, I can take this whole. Okay, so this is the term. Now I'm going to write down like this. Okay, let's say I can write down this here. Oh wait, this z should come, this j should come here. Okay, wait. Yeah, so if I will find out the partial derivative with respect to x, that is going to be 4 plus 2z I cap. Okay, then this is the partial derivative with respect to y. If I will take the partial derivative with respect to y, there is no term of y, then it will be 0 j cap. Then partial derivative with respect to z is going to be 0 plus 2x k cap. So the divergence, so the gradient of divergence, basically this will be 4 plus 2z I cap plus 2x k cap. Okay, this is the answer of our second question. Now the third one is find out the gradient of this curl. Can we find out this? Now it is not the gradient, this will be the divergence. Now let me explain. What was the question? The question was delta cross f vector. And what is your f vector? F vector is basically 0 I cap. Okay, let me copy this thing. So it is basically 0 I cap. Yes, so this is 0 I cap. Yeah, so this is del cross f vector, so 0 I cap minus z square j cap plus 2y k cap. So here, because of that, it is a vector quantity. Okay, this is a vector quantity, and I'm going to apply this. So this is called divergence of curl f. So divergence of curl f. Now you apply the divergence. So that is basically dou f1, that will be 0 by dou y, sorry, x. There is no ij will be there because I dot I will be 1. Okay, so it is dou by minus z square with partial derivative y, and this is 2y upon z partial derivative with respect to z, that is going to be 0. Always keep remember divergence of curl will be 0. Okay, this is how we can solve. And next will be the curl of this. So again you have to apply this thing. So this is your curl. Now you are going to applying I, j, k. This is curl of curl. So dou by dou x, dou by dou y, dou by dou z, and that is going to be 0 minus z square, and this is 2y. Okay, this is how we can solve the these different kind of differential operators, and this is how we can apply the like your derivative operators. Okay, that is basically called line integral, and it is very important. Okay, so basically the line integral is the concept of line integral is a natural extension of the like a definite integral. In the definite integral, there is no direction for the curve, but here there will be the direction. As I explained you, there are, okay, before going to start this line integral, there are some like there are few points to keep in your mind. So first one is that r vector is nothing but xi cap plus yj cap and zk cap, called position vector. Okay, what do you mean by the position vector? That let me explain. So this is a point, let's say x comma y comma z. So a vector which is from origin, that is called r vector. Okay, position vector. This vector is known as the position vector. Okay, for any point p, I cap, j cap, k cap, and these are the coefficient of, these are the coordinate of this. Okay, so this is, and if I'm going to find out the like distance or the magnitude or the length, then it will be always calculated from the origin. So 0 comma 0 comma 0. So the distance will always be x minus 0 whole square, y minus 0 whole square, z minus 0 whole square, that is something x square plus y square plus z square square root. Okay, that is called the distance of the like this position vector. Okay, now next point is that called a parametric form. Okay, so this is basically a parametric form because we are going to integrate a curve. We are going to find out the curve in a linear form. Okay, from a to b. So in that case we may need the form of the parametric curve. So what do you mean by the parametric form? Parametric form is basically let's say this is, if I have a curve which is in x, y, z. Now it means it is in 3D. If I want to convert this into 1D, because this line integral can handle only 1D, one dimensional integral. Okay, so let me explain. Let's say I have a single integral, then I can only integrate like this kind of integration. If I have f of x comma y, then I have to use double integral. If I have x, y, z, then I have to use the triple integral. Okay, that's the concept. Simple. So here what I have to do, I have to convert this double integral to the one single integral. Okay, how I can do that? So using that, I have to convert this function of two variable or several variable into a function of one variable. That is called the that is using the parameter. So that parameter is basically, let's say, let me take one example and then I'll explain you. Let's say I have y is equals to x square. Okay, okay, this is a curve. Now there are two different variables. Okay, basically the variable is x square only, but if I'm going to integrate this, I can easily integrate this x square like this. If I have, let's say, f is equals to x square plus y square, how can I convert this to let's say to a one variable like coordinate? Okay, this is a circle. So to find out this into one variable, I will use x as sine, x as cos of t, okay, and sine y as sine of t. And now you will say, why are you using this? Because of that, these are satisfying this x square plus y square. Let's say it is a circle, then it will be x square plus y square, cos square theta or cos square t plus sine square t, that will be 1. That is satisfying this. Now what will happen with this? If I will write down like this, so it is cos square t plus it is sine square t. Now see, this both get converted into a single variable, that is only t. Now I can easily apply line integral. Okay, let's take this this example, this parabola example. Let's say y is equals to x square is the parabola. Okay, if I'm going to integrate this, let's say y minus x square. Now this is a double integral. I can't apply the line integral here. This is there are two variables. Let's say I have this equation and I want to integrate this. Then what I will do? So in that case, I will consider, let's say x is equals to t. Then I can convert my y is equals to t square. Now I can easily write down t square minus t. Oh, sorry, that will be t square minus. Now when you will apply to this, this is satisfying this. Now you can easily find out the integral. So that's the basic concept. Okay, this is called the parametric form, and we are converting, we are assuming one variable as some parameter, and then all other variable can be expressed in terms of that particular parameter. This is the basic concept. Okay, now let's begin with the question, then only we'll understand how we are applying this all like line integral kind of thing. Okay, now let's okay, before going to that, there are some formulas of this. Okay, we'll explain by the questions only. Let's take a question, then you can easily understand this. Let's say I have this curve. Okay, f is equals to x square. Okay, before going to this, I think, okay, I should explain this one. How to solve this? Evaluate the integral, or basically the line integral of f vector. Okay, what is the format for the line integral? That is basically line integral is something like this: f dot dr vector. Okay, f is a vector quantity. Let's say x I cap plus y j cap. What is r? Dr basically. So r vector is nothing but x I cap plus y j cap. For now I am taking to the 2D only. I am not going to the zk cap. Okay, for 2-dimensional. What is dr? Dr is basically the total derivative of this is nothing but dx I cap plus dy, that will be dy j cap. Okay, so it is nothing but your f dot dr is basically, okay, along this curve C. Okay, so this is called line integral along this curve C. F dot dr, f is basically, every time f will be f1 I cap plus f2 j cap, and this is your dx I cap plus dy j cap. So simply I can write down like this. This is nothing but f1 dx plus f2 dy, and the limit will be according to this C. So from here, okay, make it simple. Now I have this f and this dr. You just take the dot product because I want to find out f dot dr. Now you write down f dot dr here. That is x I cap plus y j cap dot dr is basically dx I cap plus dy j cap. Now you multiply this. That is basically x dx plus y dy. This is your f dot dr. Now you apply the integration over C. That is basically x dx plus y dy. Okay, now here the concept is what will be the limit. Now come to the point. So the limit is basically, it is saying that it is from 0, 0 to 1, 1. It's along a line. Now let's take a line. Let's say I have this one. Okay, wait, let's say, okay, wait, yeah. This is 0 comma 0, this is x-axis, this is y-axis, and now I want to convert, okay, I want to draw the line, and that will be a simple line. So let's take a line 0 comma 0 to let's say 1 comma 1. This is 0 comma 0, and let's say this is 1 comma 1. Okay, so this point is, let's say, 1 comma 1. Along this line I have to find out line integral from this O to, let's say, A point. Okay, and what is my integral? And this is a curve C, and integral is x dx plus y dy. Because of that, this is line integral. I can't directly write like this. Okay, one concept is that you write down x dx plus integral of y dy, then you apply the limit of x. Now this is x comma y, and this is also x comma y, then you apply the limit 0 to 1 x dx, and it is 0 to 1 y dy. This is a way to find out the solution. In this way you can easily find out the solution. So what it will be? It will be x square upon 2, this is 0 to 1, this is y square upon 2, 0 to 1, and it will be 1 by 2 plus 1 by 2 is equals to 1. This is a method to solve this. Okay, this is method 1, and this is very simple case, so that's why we could solve this using this method. Okay, so this is something, let's take method 1. In this case we don't need of the parametric form, but let's say if we are using the parametric form, then how we are going to use the parametric form, and why the parametric form is very, very important. Now let's come to the method 2. What is the method 2? So method 2 is basically, you simply, because of that it is x and y both, then you convert this into a simple line. This is in 2D. I can convert this into a linear. I can convert this into simple only let's say only in t. Let's say x is equals to t. Okay, x is equals to t. How can I convert this into t? And one more thing, this is very simplest case, because of that it is a linear kind of thing. Okay, so before going to this, you have to find out the equation. What is the relation between x and y here? And I know that this is a very simple equation, that is y is equals to x line. This is y is equals to x line, theta is equals to 45 degree, pi by 4. I can easily guess this thing. Or else, if you don't know how to find out the equation of line, then you can apply this y2, or you can apply this y minus y2 is equals to y2 minus y1 upon x2 minus x1. Okay, this is basically the equation of line passing through 2 points, that is x minus x1. Okay, x minus x2, no, x minus x1, yes, y minus y1. Now it is y minus 0. Let's say this is x1 y1, this is x2 y2. Okay, this is 1 minus 0 upon 1 minus 0, and this is x minus 0. When you will solve this, you will get x is equals to y. This is a simple line. Now if x is equals to t, what y will be? Y is also t. Now I have converted this line in 2D to 1D. That is what this is. My t is equals to 0. Okay, and this is t is equals to 1. So simply I have taken the projection of this in 1D, that is called parametric. Now it is a parametric. This line will behave as this line. Okay, now what to do? Okay, we have solved this thing, and now come to the point how to solve this integral. It's very okay, this is very easy, but I'm just explaining you. I'm just taking time to explain you the things. Now come to the point. We know that this is a line, basically y is equals to x. Okay, this is a line, basically y is equals to x. This is the relation between x and y. Sometime it is given in the question, sometime if it is not given. If it is not given, then you can easily establish that relation. So now from here I got the y is also t. Now what? Simply put these values here. So what is this? X is t. Now if x is t, then what dx will be? So from here dx is nothing but dt. From here dy is nothing but dt. You apply this, so it is t dt. Y is also t, and this is dt. So what it will be, it is nothing but 2t dt, and t is from where to where? T is from 0 to 1. So this is from t is from 0 to 1, this 2 outside, this will be t square by 2, and when you will apply the limit from 0 to 1, it is nothing but 1. So this is the answer. So these two are the cases. Okay, this works, this worked because of that it is the simplest case, but this will not work for every time. Okay, then you have to go for this. This is parametric form, and this is the concept of parametric. We could convert this 2D curve to linear or 1D curve. Okay, this is how parameter things work. It's how parametric things is working. Next, come to this point. Okay, now come to this example. We'll explore this example. Okay, let's take the example that is x square plus y square, and this is y square into yes, this is x y square x. Now here the thing is, the y square x relation is given. See, f is equals to x square minus y square plus x I cap minus 2xy plus y j cap, and the curve is given, that is y square is equals to x. It means it is a parabola on, it's a parabola like this. Wait, I think it should be start from here. So it will be, it is a parabola starting from here basically. I think I can draw the parabola also. Okay, let it be, I can draw like this. This is y square and x square. Now it is from 0 comma 0 to 1 comma 1 only. So this is 0 comma 0 to, let's say 1 comma 1 is here, 1 comma 1. Then you have to find out the line integral from here to here. Okay, again, now here no need to establish the relation. This is the relation is given. So from here, what is f dot dr? Because you are going to calculate the integral f dot dr along this c. This is your c. Okay, so this is basically 0 comma 0 or f dot dr. So I will simply first find out the f dot dr. We all know that dr is nothing but dx I cap plus dy j cap. If z component is there, then we can write dz k cap. Okay, so it is basically equals to x square minus y square plus x. And my simple advice is that whenever you are doing the dot product, you just replace I with the dx, y with this. Okay, or you just apply the integral, replace I with dx minus, and this is your 2xy plus y, replace j with dy. Okay, now you integrate this along, but the problem is again it is in the form of xy. Now here see, y is with x, now here x with y. Here it is not simplest case, we can't apply this particular case here. So you can see we can't separate the variables like this, so we have to use the parameter for sure. Okay, so we'll use the parametric form. So let's let x is equals to t, then y is the relation, that is t square. So from here we can get dx is equals to dt, and from here we can get dy is nothing but 2t dt. Now you apply this values here, and again of course t is going from where to where. So x is 0, then t is also 0, x is equals to 1, then t is also 1. Then you can apply this value here. So t will be from 0 to 1, of course. So here t will be from 0 to 1. So you apply 0 to 1. So it is x square, that is t square. Okay, y square will be t power 4 plus x will be t, dx will be dt minus 2 into t square, and plus y will be your t square, and dy is nothing but 2t and dt. Okay, now we will solve this integral. It is very simple integral, so linear like definite integral. We can easily solve this integral. So now here we will solve this integral. Okay, so this is basically dy, and we will solve this integral 0 to 1 dt, or I can write down like this, t square. First we will simplify, t square power 4 plus t minus it will be 2t cube plus t square, and it is okay, basically 2t is also there, so let me multiply 2t with this, so it will be 4t power 4, okay, and minus 2t cube dt, because this 2t is there. Then it is 0 to 1, then t square minus 4t, so it will be 5t power 4 minus t minus 2t cube dt. Now you simply apply this limit, so it is t cube by 3 minus 5 t power 5 by 5 minus t power 2 by 2, 2 into t power 4 by 4, and limit is from 0 to 1, so it is basically 1 by 3 minus 1 minus 1 by 2 and minus 1 by 2. Okay, so it is 1 by 3 minus 1 minus 1, so it's going to be 1 by 3 minus 2, and it is basically 3, 1 minus 6 is basically minus 5 by 3. So this is the answer. This is how you can solve. Okay, so now let's come to the next question. Now here it is given that z x y. Okay, so let's say it is f is equals to yes. So yeah, one more thing is that is very important. Sometimes there are okay, one more thing, I am solving here the question that is basically all different types of question. Okay, see this question. In this question, y and x, the relation is given, as the point is also given. Here the relation is not given. We stabilize the relation, that is y into x, and then we could get the relation, and then we can convert into the parametric form. Now here r is given. Earlier r was not given. We were considering r as x I cap plus y j cap and z k cap. Here r is given. That is an important thing. So whenever the r is given, then what to do in that case? So if your z is given like this and r is given, then what to do? Let's say f. Now here f is also given in the different form, that is z x y. So this is nothing but z I cap plus x j cap and y k cap. Okay, don't worry about this. You can simply write down like this. Now the concept is that r is given, and that is given in the parametric form. How it is given? It is given r, that is cos of t I cap, okay, plus sine of t j cap plus 3t k cap. So basically it is the same r. Okay, same r like x I cap plus y j cap and the z k cap, but they are using the replacement. For x is equals to cos of t, y is equals to sine of t, and z is equals to 3t. Okay, this is important thing. It means you have to convert, because it is in t and it is in x y, you can't directly dot product. So you have to convert this f into t first. So that will be, what is the z? Z is 3t, so it is 3t I cap. X is cos of t j cap, and this is sine of t k cap. Now these both are same, then you can multiply or you can find out the dot product. Okay, so in this case, and this r is the, like this is basically the helix. Okay, this equation is for the helix. So what do you mean by helix? That I will explain later. First let me solve this. So now here it is basically f dot dr. Now it is r. I want f dot dr. Okay, so as the curve is given, curve is not given. Okay, anyways, this is given in the form of 0 to t, so it is from 0 to t, because all will be converted to t. So here it is basically from 0 to 2 pi. Okay, and f is 3t I cap plus cos t y j cap, and it is sin t k cap. Okay, sin t into k cap, sin t k cap. Dot product of dr. What will be the dr from here? Derivative of cos t will be minus sin t, okay, minus sin t dt I cap, plus derivative of sin t is cos t dt j cap. Derivative of 3t is 3 dt k cap. You write down here minus sin t dt I cap plus cos t is basically cos t into dt j cap plus 3 dt into k cap. Okay, this is the dr. You have to find out these values. Now you apply this. Now when you will multiply, this will be I dot I will be 1. Okay, so it is 2 pi, so that is basically minus 3 t into sin t dt, that I will take common, plus it is basically cos square t, okay, dt I will take common, then it is 3 sin t dt. Okay, when you will solve this, you have to apply eilate here. Okay, you have to apply cos square formula. When like cos square formula will be 1 plus basically whenever you have sin square cos square, then you have to apply this formula. Okay, so this is basically cos 2t. Cos 2t is basically 2 cos square theta minus 1, and it is also 1 minus 2 sin square theta. So if you have cos square theta, then you can simply write down cos 2 theta plus 1 upon 2, or if you have sin square theta, then you can write down like this, 1 minus cos 2 theta, okay, divide by 2. So it is cos square theta, then you apply this formula here. Then when you will solve this, this will be 7 pi. Okay, this is your answer. And one more thing, as I explained you, this is called helix. So here helix is basically a 3D curve. So because of that it is in Z, then I will explain in 3D form. So it is basically a 3D form like this. Let's say I have this Z axis, okay, this is x axis, and let's say this is y axis. Then this curve is basically starting from here. This is circle. See, here it is a circle, x plus xy, and something like this. It is also going in the z direction. So this is like this, is called helix. This is the equation of cos t I cap plus sin t j cap and 3t. 3t representing its radius from span from the origin. Okay. This is called helix. Now come to the next point. Let's say next question is related to minus x minus y, f minus x minus y, and here it is curve is not given. Okay, again find out the value, and in the circular arc. Okay, this is here given the circular arc. So in this case, let's say I have this f. So what is your f? So f is equals to minus y I cap and minus let's say it is minus y I cap minus x j cap. Okay, it is given, means it's the coefficient of I and the coefficient of j. C is the circular arc. So if it is circular arc, means it is x square plus y square is equals to 1. But the thing is that circular arc from A 1, 0 to B 0, 1. Okay, let's take this. What do you mean by this? This is xy. Okay, and this is basically a circular arc like this. So let's say I have this circle. Okay, so this is a circular arc from this one. Okay, so this is like this. Wait, let me change the color. I think I can change the color. Wait. Okay, wait. Yes. Okay, let me draw the whole circle like this. So I have this one. So this is a circle. Okay, so this is of circle of radius 1. Okay, this is 1, 0 and this is 0, 1. Okay, of course x is 0 and here y is 0. So the integral is of this particular thing. Okay, so we have to find out the integral from here to here. Okay, of this portion only. How to find out? So in this case, whenever you have circle is given and you have to convert into the parametric form, I will give you the concept. Okay, f dot dr. Now here dr, what is the dr? Again the concept is for the dr. So r is basically xi cap plus yj cap, then dr is basically dxi cap. Okay, dxi cap plus dyj cap. You have to find out the integral f dot dr. So your f dot dr is basically integration of minus y dx, replace your I with dx, and this is x minus dy. Okay, this is along this curve C. Now the problem is this is y and this is x. You have to convert into the parametric form. Okay, convert into the parametric form. To convert into the parametric form, and every time if you have a circle, then what will be your parameter? Again, you can simply write down x as t, but this will be problematic for you because y will be 1 minus root t square. Then the integral will be very different. So this is slightly related to the polar coordinate system. So what you replace x with cos of t and y with sine of t, and you apply here. This is satisfying or not? Yes, it is satisfying. It means r is 1, then you put r cos t, that is r1. Now when once you will apply, so you can find out dx is nothing but, what is your dx? It's the minus of sine t dt. What is your dy from here? That is basically cos of t dt. Now you apply it here. So what is our integral? So our integral is basically like this. So integral is nothing but f dot dr. So from here, once we will replace it, so it is basically dx is minus sine t dt, dy is cos t dt. Once I will apply, so x is equals to cos of t, y is equals to sine of t. Now you apply it here. And one more thing, what will be the t value? T is the angle is from, this is 0 and this is pi. So 0 to pi by 2 will be the limit of t. So the integral limit will be from 0 to pi by 2, and minus y will be minus sine t into dx is minus sine t dt. Okay, or dt I can take common. Then it is minus of x is cos of t, dy is again cos t, and dt I will take common. So it is basically 0 to 2 pi, and what it is basically minus of sine square t. This is minus of cos square t dt, and I can write down like this: 0 to pi by 2, I can take minus common. So this is sine square t plus cos square t dt, and it is basically 0 to pi by 2 1 dt, and that is nothing but minus pi by 2, which is the answer for this question. Okay, this is how you can solve. So there are different types of question. Let me explain again. So we have started with this question. Okay, we have started with this line integral, we have started with this question. So this is the question in which xy given, and you convert it into parameter. Here xy relation is not given, we stabilized using the line, we using the equation of the line. And then here it was given r was given in the parametric form, and here r was given in the circle. Whenever you have circle, you use this particular replacement. Okay, so this is what how you can use this thing. Okay, now come to the next topic, that is work and flux over the simple closed curve. Okay, so before going to this, I will simply explain you what do you mean by the simple closed curve and like simple connected curve. There are different types of this. Okay, so simple curve means this is the simple curve. Okay, but this is not simple curve. This is closed curve, but this is not simple closed curve. Okay, there are different things. So we'll see the work and the okay, now let's start the topic, that is work and flux over the simple closed curve. Okay, so first of all, what do you mean by the work? So work is basically force into displacement, f dot dr. If I will take the integration of this, so work. So whatever we have solved the previous question, that is all related to the work. Now the concept is that to find out the work, there is a concept. If your f is a conservative field, so I'm going to explain you the proper like flow of the work done and the flux. So this is called something line integral. Okay, so let's say if you have line integral, and the thing is that whatever your f, that is a spatial f. It means if this f has curl 0, if I will find this curl, this 0, if curl is 0 means there is no rotation, it is called irrotational, or it is called conservative vector field. if once it is conservative vector field, then it has f, I can write is equals to delta into phi, and again this phi is a scalar quantity, and this is called scalar potential function. Now you will say, sir, why do you need this scalar potential function? What we will do with this? If I could write f is del phi, then what will be the what will be the advantage of this? So I'm truly saying the advantage of this is nothing but this is from here. So if I will find out the f dot dr, this is called line integral. So this line integral will nothing but a to b, this f dot dr is going to be d of phi. If it is d of phi, then I can simply write down it is phi b minus phi a. This is called flux, or this is called work done, and this is again going to be here. See, this is a fundamental result for this. So this integral can be written in terms of phi b minus phi a. This is work done. Okay, it's not flux, it's a work done. Now that main problem is, okay, to start the question, you have to first find out whether it is a conservative or not. Then you have to go for phi is equals to delta phi. F is equals to delta phi. Now your task is to find out phi. How will you get this phi? You have to find out the phi. That is very, very important. Okay, so to find out the phi, I will explain how to find out the phi. Once you got the phi, then you can easily find out this f dot dr. Okay, once let's solve the problems related to the scalar potential function. How to get the scalar potential function? This is a conservative field. When you will solve this f dot curl of phi, this will be 0. You can check like this: I, j, k. All of you know how to find out the curl: dou by dou x, dou by dou y, dou by dou z, and this is y plus z. Okay, this is z plus x, and this is x plus y. When you will solve this, this will be 0. Okay, once if it is 0, then I can write down this phi, this f as delta phi. So what is this phi? My target is to get this phi. How to find out this phi? Okay, so the trick is, okay, but the problem is with this, because this is a reverse process. From derivative to we are getting this. So we have to find out the integral. To find out the integral, what we will do? So we will write down this f. I'm going to share a trick with you. So phi y plus z I cap plus this is z plus x j cap, and this is x plus y k cap. Okay, now what to do? You replace your I with dx, j with dy, k with dz. Okay, so this will be the delta phi. That is going to be y plus z. Okay, not delta phi. You write down d phi. Okay, you write down d phi. Delta d is a derivative. This is y plus z dx. Okay, z plus x dy, and x plus y dz. So basically we have multiplied f dot dr. So this is nothing but f dot dr. F is basically delta phi. Okay, and this is basically dr. So all of you know that what is this? This is dou phi by dou x I cap plus dou phi by dou y j cap, and dou phi by dou y, and this is z, this is k cap. Dot product with dr means dx I cap plus dy j cap and dz k cap. After multiplying this, this is dou phi by dou x dx plus dou phi by dou y dy plus it is dou phi by dou z dz. It is called total derivative, so we can easily write down like this. So this is how we came from here to here. In the right hand side, I will multiply to the dx I cap. That will be like this. Now what to do after this? That's the concept. So you simplify this. This is y dx plus z dx plus z dy, okay, plus x dy plus x dz and plus y dz. Now we will use the inspection rule. It's a very, very important reverse process, and I will tell you, it's this trick will 100% work. See, this is dx. If I'm going to integrate these all terms here, the integration of y with respect to x, it's not possible. Integration of z with respect to x is not possible. So it means that if it is y with x, then of course there is a term where x with y or x with dy. So you keep that term and write down here. This is y dx, then of course y dx dx will be there, then it will be x dy. Now you see, this is your z dx, you write down z dx, find out x with dz. See, this is x with dz, write down x with dz. And then this is what z with dy, you write down z with dy, and of course there will be a term in which y with dz. So this is y with dz. Now you apply this one. So this is your d phi is equals to, what is this? Can you think like this? It is a multiplication of xy and its derivative. Okay, it's a derivative of u into v. Once I will solve this, y outside, derivative of x, x outside, derivative of. This is a reverse process. So it is basically d of yx plus it is d of zx and it is d of zy. Once I will integrate this. When I will integrate this, I can easily get this is yx plus zx plus zy. This is your scalar potential function. Once you get this scalar potential function, then you can easily find out the integral. That is our main target. Now come to the next question. In this question here, what is that? Check whether f is, okay, it is given that if f is a conservative, then find out the scalar potential function and also find out the work done in the moving particle from this point to this point. It is a point, it is b point. So our simple target is, the problem statement is find out this one. Okay, first target is find out phi. Phi is nothing but f, which is delta of phi. We can easily get, we have solved the previous problem. And second is find out a to b f dot dr. This is called work done. Okay, this is what we have to calculate. Okay, now how to calculate this? Because of that, here we have to find out the work done. Okay, let's start with this question. This is the question. So you can easily check the curl is basically, it is given, but the curl is 0. Once you will check, the curl will be 0. Okay, now you come to here, how to find out d phi. So to find out the scalar potential function, okay, so the solution for the first to find the scalar potential function, you write d phi at the place of f, 2xy plus z cube, I replace with dx, x square, j replace with dy, 3xz square replace with dz. Okay, now you simplify. This is d phi, this is 2xy dx plus z cube dx plus x square dy plus 3xz square dz. Okay, now you see. Okay, let me copy this and take it to the next page. Wait. Okay, see, this is your d phi. Now here, this is y with x. And of course there will be something. Okay, wait, I think it is x square dy. It's not wait, it is 2xy dx, yes, z cube dx, and next one is x square dy. Okay, dy is not here, it is dy. Okay, so it is y with dx and it is x with dy. Okay, so this is basically d phi is equals to, you can easily write down like this, 2xy dx with, see, this is x square and this is dy, and what is this? This is z cube with dx and here x with z, so it will be 3x z square dz. Now you can think, see, it is the derivative of 2x and y. Now x and y, this is x square, so of course it is x square y, plus reverse process, this is z cube into x, so of course z cube as it is and x will be like this. Now you can verify that whether it is same or not. Once you will derivative, take x square common, or derivative of y dy, y square as it is, derivative of x is 2x and then it is dx. See the same thing. Once you will take like this, z cube common, it is dx. Okay, x common and the derivative of z cube is 3z square dz. It's the same thing. This is how you can simplify this thing. Okay, now come to the next, integrate this. This is d phi, integration of d of x square y plus integration of d of z cube x. Now it is phi is equals to integration and derivative nt plus, and it is z cube and x. Oh, this is your phi. Okay, first target completed. Now second target, find out the line work done from a to b. This is f dot dr. It is nothing but phi of b minus phi of a. Okay, otherwise you have to solve the complete integral from a to b. Now this is 1 comma minus 2 comma 1. So this is phi at b. So what is your b? It's 3 comma 1 comma 4 minus phi of this is 2 comma I think 1 comma minus 2 comma 1. When you will apply this thing to here, so this is going to be 9 into 1 plus 3 into 64. Okay, minus this is 1 into minus 2 plus 1 into 1, that is nothing but 9 plus 192 I think. Okay, wait. This is basically 9 plus 192 minus, this is basically minus 2 plus 1, and that is again nothing but 202. So this is your final answer for this. This is how you can solve the work done using conservative concept using phi. First of all you have to find out the phi and then you have to solve the conservative. Now next one is flux. Now the next story, what do you mean by the flux here? So the formula of flux is basically it's a work done, but the problem is this, the additional term is there, that is the n is the direction here. Okay, so the direction is only additional term here. We are going to use this, and to find out the flux we will use this formula m dy minus n dx. So what do you mean by m dy minus n dx? So basically m, every vector field will be like this, m I cap plus n j cap. In this case we will find out the flux. So this will be m and this will be n. Then replace your I with dy, this will be dx, and we will apply this formula to here to find out the flux. So we will use this formula m dy. Okay, m dy minus n dx. How to solve this? Let's take the example. This is the question. Find out the flux. Okay, let's take this question, x minus y, I cap and j cap. Wait. Okay, so how to solve this question? So in this case, find the flux of the vector f is equals to 2x I cap plus x minus y j cap, and r is given here, r is equals to a cos of t, again it is given in the parametric form, plus a sine of t j cap. Okay, and t is given from 0 to t. So what is the formula? So the formula for the flux, so the flux is equals to closed integral m dy minus n dx. What is your x from here? X is a cos of t, y is equals to a sine of t. So from here dx is nothing but a minus a sine t dt. Okay, and dy is a cos of t dt. You replace it here, and from here what is your m? So m of x comma y is 2x, and n of x comma y is basically x minus y. So once you will apply, convert this into t. So m of t is basically you have to apply this formula, this value, so that will be 2 into, okay, that will be 2a cos of t, and convert your n in t, that will be x. So a cos of t minus a sine of t. Now you apply these values here, that's the simple concept. So your phi will be, this integral will be m dy minus n dx. Apply this. Once you will apply this, that will be from 0 to 2 pi. M is 2a cos of t, dy is a cos of t. From here dy is a cos of t, so it is a cos of t. Dt I will take common, okay, minus it is a cos of t, a sine of t, and dx is basically minus a sine t, so it is minus a sine t and whole dt. Okay, once you will solve this, when you will simplify this, you have to simplify. Okay, let me simplify complete. So this is 0 to 2 pi. Okay, so this is 2a square cos square t plus this is a square. Okay, when you will multiply here, it is a square sine first, okay, sine t cos of t minus a square, this minus plus, and this minus will be minus, so minus a square sine square t, and this is dt. Okay, next here what you can do, so from here let's take 2a square common. Once I will take not common, yeah, one by one we can solve. This is 0 to 2 pi, this is cos square t dt, plus it is a square, take common, 0 to 2 pi, this is sine t cos t dt, minus a square outside, 0 to 2 pi, this is sine square t dt. Now you can directly apply the formulas of the replacement. All of you know that cos square t is 1 plus cos of 2t upon 2, and sine square t is 1 minus cos of 2t upon 2. So this is from this formula. Cos 2t is 2 cos square t minus 1 and 1 minus and 1 minus 2 sine square t. This is from this formula. Okay, now from here, because of that it is odd, so this will be 0. So from here this integral will be 0 using eyelet, or it is odd, so it will be 0. Not odd, I think. Yeah, it's when you will apply this sine to cos t for a whole circle, that will be 0, and this will get equal. So when you will solve this complete, so this will be 2a square into pi plus 0 plus, or sorry, minus a square into pi. So this is basically 2 pi a square minus pi a square, and that is going to be pi a square. This will be the answer of this integral. Okay, this is how you can solve this. You replace and then apply this formula, and then you can get the answer. Okay, next, this was related to the flux. Okay, every time you have to apply this formula flux, and then you have to solve. So the next concept is Green's theorem and the surface integral. This is again very important theorem. Now we'll end up to the main core like part of the integral calculus, that is called Green's theorem. We will convert our double integral problem to the single integral, or you can simply say the line integral problem can be solved using the double integral directly. Okay, let's say I have to find out the area of this square. Okay, and to find out the area of this square, what I will do, or let's say I have to find out the line integral, not area, to find out the line integral of this along this a to b, b to c, c to d, like from here to here, here to here, and like this. Then what to do? So in this case, we have to solve 4 line integral formulas. Okay, first one, this one, then this one, then this, and then this. But using this Green's theorem, what we will do, we will take delta f2 by delta x minus delta f1 by delta y, and then we will apply the area concept. Then it will give you the, in the single integral, it will give you the line integral. Okay, this is how we will solve. And the surface integral, these are the formulas for the surface integral. Okay, first we will focus on the Green's theorem. Let's say I have this, evaluate the line integral. This is the line integral given. So line integral y square minus 7y dx plus this is 2xy plus 2x dy. Okay, and by using this, you apply this by using the Green's theorem and then solve this. How can we find out the solution? Okay, so it is basically that verify this Green's theorem. What do you mean by the verification? So verification is basically something, because of that it is a circle given. So okay, first of all we will solve using the Green theorem. Okay, so the solution using Green's theorem, that is x square plus y square is equals to 1. What is the formula for the Green's theorem? Let me recall. If you have f, that is m I cap, okay, plus n j cap, and the formula is double integral, okay, the single integral m dx plus n dy will be written in terms of double integral over s, the partial derivative of second with respect to x, okay, partial derivative of second with respect to x and partial derivative of first with respect to this, and then dx dy, or you can write down dy dx. So simply you apply. So what is your m here? So from here m is equals to 2x, this is your m, means the coefficient of j, coefficient of dy from here, okay. So 2xy plus 2x, sorry, this is n, wait, I made a mistake, the coefficient of dx, this is your m. So y square minus 7y, and here n is 2xy plus 2x. So partial derivative of m with respect to y, that is 2y minus 7, partial derivative of n with respect to x, that is 2y plus 2. Now you apply the double integral, okay, this is double integral, write down dou n by dou x, means this one 2y plus 2 minus this is 2y minus 7, okay, and then dx dy. Because of that it is a circle. Then again, how to solve this double integral? First of all, let me simplify this. Once I will simplify, it is 9 dx dy, and it is 9 into double integral dx dy, and this is a circle. This is basically the area of circle, okay. So how to find out the area of circle? So from here it is basically double integral 9 dx dy, it is given x square plus y square is equals to 1. Convert into polar form, okay. So from here the polar form is what? X is equals to r cos theta, y is equals to r sin theta, and dx dy is nothing but r dr d theta. So take 9 outside, okay, then you apply the formula. So from here r is basically 0 to 1 because radius is 1, and theta is from 0 to 2 pi for it's the covering the whole circle, okay, and dx dy is basically r dr d theta. Then it will be 9, okay. So it is 0 to 2 pi, integration of r is r square by 2, it is 0 to 1, and this is d theta. Then it will be 9 by 2 into r square, it is 0 to 1, and it is 2 pi. So basically 2 and 2 will get cancelled, so the answer will be 9, and 1 minus 0 into pi, so the answer will be 9 into pi. This is how we can solve using the Green's theorem. But to verify the solution, you solve by taking parameter of a circle. So in that case, how to solve this question? Okay, so now to verify, let's take to verify this question. Okay, let's say this question is verification. It means now here you have to solve this problem using this problem. This is the problem y square minus 7y dx, okay, plus 2xy plus 2x dy, using the simple line integral concept, okay, line integral concept. So now in that case what you have to do, you have to convert. Take x is equals to cos of t, y is equals to sine of t, because it is a circle given, x square plus y square is equals to 1, okay. Then find out dx is equals to minus sine t dt, okay, dy is equals to cos of t dt, you replace it here. So now from here, okay, again t will be from, because it is sine square cos square t, so here from here t will be from 0 to 1, so t will be from 0 to 2 pi, so it is from 0 to 2 pi. So this is y square. What is y square? That is sine square t minus 7 sine t, dx is nothing but minus sine t dt, okay. Now plus this is 2 into x is basically cos of t, y is sine of t plus 2 into cos of t, and dy is cos of t dt. Okay, then you have to simplify 0 to 2 pi. This is basically when you will apply, this is minus sine cube t plus 7 sine square t plus this will be 2 cos square t sine t plus 2 cos square t dt. You have to solve this integral. When you will solve this integral, you will get 9 pi. Okay, now you can see which one is easy to solve this line integral. This one is very easy to solve. This is what you have to apply this formula and you have to calculate this value. Okay, this is a question related to the Green's theorem. Now let's take one more example. Let's say I have this question, evaluate the line integral. So now here again it is given that line integral is xy into dy. Okay, xy into dy minus y square dx. So first target is what? Identify m. M is the coefficient of dx or coefficient of f. This question can be given like this: find out f dot dr, in which f is equals to xy j cap minus y square k I cap minus y square I cap. Now which one will be your m? M will be the coefficient of I cap or coefficient of x. Don't get confused with this, it is very very important. This is your n because it is dy, this is your dx because it is m. Okay, so you write down here. So m is minus of y square and n is xy. So the derivative of first with respect to second variable means the derivative of m with respect to y and the derivative of n with respect to x. So that the derivative of m with respect to y is minus 2y and the derivative of n with respect to x is only y. Now you apply this formula. So here it is not written that verify, so no need to find out both the sides. Okay, you apply the Green's theorem only. So while applying the Green's theorem, that is basically the partial derivative of n with respect to x minus partial derivative of m. Okay, partial derivative of m with respect to y, and then take the dA. dA means dA dx dy. Okay, now see, this is what when I will apply this, so it will be double integral. Okay, so this line integral will equals to the double integral. Let's say this is your I, so I is equals to the double integral. This is y minus minus plus 2y, and this is dA. See, this is x is equals to 0, y is equals to 0. This is y is equal, x is equals to 0, y is equals to 0, x, y, this is x equals to 1, y equals to 1. It's a circle. So just what are the limit for this double integral? 0 to 1. This is 0 to 1. This is 3y dx dy. When you will solve this, you will get the answer as 3 by 2. This is how you can easily apply the Green's theorem to this question. Next question again, which is also related to the apply this to find out, let's say x square 0 3. Okay, in this case how will you apply this? Okay, so in the portion of the first octant, okay, f, and it means you have to find out the flux here. I think this question is not clear. I think this question is not from this portion. Okay, let me check. Okay, yeah, this is the question which is related to the surface integral. This is not the question of this line integral. Okay, this is related to the surface integral. Now come to the point, how to find out the surface integral. Okay, so first of all, to find out the surface integral problems will be given like this: double integral, this is surface n cap ds, this is the surface. To find out the surface integral, next we are going to use the Gauss divergence theorem. But how to find out? Simple, using the double integral. So what are the formulas? So let's come back to the formula slide. So this is these are the formulas. So whenever you have f n cap ds, then you convert. Okay, first of all, your target should be consider x is equals to u, y is equals to v, z in terms of u and v using these relation. This should be your first target. Then second, you find out r is the position vector. Okay, then you find out the partial derivative with respect to u and partial derivative with respect to v, and then you apply this formula. That will be the surface integral. Okay, Now this is the surface integral theorem and surface integral using this formula. Let's say if I want to calculate the surface area, in the case of surface area, because of that it is the cross product, it will contain the direction, but into finding the area I don't need the direction, so I will take the magnitude of. So this is the formula. This is also the formula of the surface integral, but this is called surface area and this is called surface integral. Let's take two example to deep dive into this particular thing. Okay, so the key concept is basically whenever you have f dot n cap ds, okay, if it is single f dot n cap ds, it is flux. Okay, if it is double integral f dot n cap ds, it is surface integral. It is written that find out the s in the portion of the plane. Now the plane is given that it is x plus y plus z is equals to 1. As I told you, here your f is given that x square I cap plus 0 j cap and 3y square k cap. What I told, convert your x, write down x as u, y as v. So what will be your z? Z will be 1 minus u minus v. So by using this, what we have done, we converted our function of 3 variable into function of 2 variable. It is a projection of a 3D to 2D, like 2D map. It's called UV transformation. Now what we have done, it is something first octant. It means x, y, z all are greater than equals to 0. In the first octant, all will be greater than equals to 0. So what it means that, it means that u, the limit of u will be from 0 to 1, greater than 0 to 1. Next, the limit of v is also greater than 0 to, okay, but the limit of v will be what? That is the case. So from here, put z is equals to 0. So it will be u plus v is equals to 1. This is the limit of u, but what is the limit of v? V will be 1 minus u. So this is 1 minus u. So basically this is nothing but like this. This is your u, this is your v. Okay, so what it will be? What u plus v is equals to 1? That is the triangle. Now you see, if this is 1 comma 0 and if this is 0 comma 1, so these are the limit. If I will take strip like this, then it will be from 0 to 1 minus, this is u plus v is equals to 1. If I will take a strip like this, then it will be u plus v is equals to 1. It means 0, v will be from 0 to 1 minus u. That's the another story. Okay, this is the triangle in uv plane. Now after solving this, you apply it here, convert your f in terms of uv. So it is basically u square I cap plus 0 j cap, and this will be 3 v square k cap. Now your f converted to r, xy, xz converted to r. Now find out r vector. So what is your ru? So okay, first of all, what is your r vector? So r means, okay, wait. So what is your r vector? So r basically x plus y plus z. You have to find out the values. So from here r will be what? X I cap plus y j cap plus z k cap. So r uv, put the values of x, that is u I cap plus v j cap, v j cap, and 1 minus u minus v k cap. Now you find out ru. Okay, let me recall. What is the formula? Formula is double integral f dot n cap ds, which is equals to, okay, convert to the this double integral. Okay, this is the double integral over the region r, this is s. Okay, then it will be f, convert into u and v, take the dot product of ru cross rv, and then next it will be du and dv. So this thing we converted. Now find out the partial derivative of r with respect to u. So it will be I cap, okay, so it will be I cap plus the v, then it will be 0 j cap plus it is 0 minus 1 k cap. So what it will be? It will be I cap minus k cap. Similarly, the partial derivative with respect to v. So it is basically 0 I cap, okay, and it will be 1 j cap and plus it is minus 1 k cap. So this is equals to j cap minus k cap. Now what is your target? Okay, let me recall. let me write down x is equals to u, y is equals to v. Okay, z is equals to 1 minus u minus v, so it is basically u plus v is equals to 1, which is a triangle in xy plane. Okay, now your f is basically f in terms of uv is u square, is u square I cap and minus 3v square k cap. So your r of u is I minus k cap and r of v is j minus k cap. Now you have to find out ru cross rv. So ru cross rv means I cap, j cap, k cap. It's a cross product. Okay, now coefficient of I for ru, that will be 1, 0, minus 1. Okay, see I j will be 0 like this. This is I 0, j will be 1. So, okay, when you will solve this, you will get I cap plus j cap plus k cap. So this is your ru cross rv. Okay, you can write down the vector also. Now you multiply this with this, so you dot product fuv vector with ru cross rv. So that is going to be I dot I will be 1, so it will be u square j, sorry, this is I think I, it's not j, sorry for that, it's not j, it's I. J coefficient is 0. Okay, when the j coefficient is 0, it is basically I. J coefficient is 0, then it complete will be 0. Okay, this complete will be 0, and this is minus 3v square, so it will be I think wait, because it is 1 minus 1. Let me check the question. It's not minus 3, it's a plus 3. Yeah, it is plus 3, so it is plus 3v square. K cap will be 1. Okay, so from here apply this formula. Now you, this whole thing is u square plus v square, so it is double integral. Okay, so double integral u square, so the surface integral will be double integral, it's a u square plus 3v square du dv, and this was your triangle. So this is u1 comma 0, this is 0 comma 1, this is uv. I'm writing uv. If I will write uv, then strip parallel to u axis. If I will write vu, let's write vu, no problem. Okay, or okay, wait, this is double integral, this is the double integral. Okay, u square plus 3v square. If I am writing du dv, first limit will be u, so u is equals to 0 to 1 minus v, because u plus v is equals to 1, and v will be from 0 to 1. Once you will solve this, you will get the solution as 1 by 3. So this is the answer. Now it is all about the solving double integral. Okay, that is a very easy concept. Okay, now come to the next concept, and that is surface area. Okay, to find out the surface area, it is very important that in the previous case we were finding the surface integral, not finding the surface area. So you have to repeat this process until here. Here what you have to do, you have to find out the magnitude. Okay, no need to find out this I. So here you have to find out the magnitude, like 1 plus 1 plus 1. So that will be the surface, like that will be the surface area. Now let's take this example and solve this example here. So to find out the surface area, how we'll proceed? So first of all, this is basically a sphere. Then you have to use the sphere coordinate system. Because of that, you have to find out only area. What do you mean by the area? So once you have to find out the area, it means here f will be 1. Keep in your mind, f will be 1, because to finding out the double integral, f dot dr, or basically area means dx dy. This is basically the area, dx dy. Now you have to convert this into spherical coordinate system, so that you have to know that. So what is that? Spherical coordinate system is basically in which you will apply x is equals to a sine phi cos of theta, y is equals to a sine phi sine theta, and then z is equals to a sine phi. Okay, where 0 this phi will run from 0 to pi, and this theta will run from 0 to 2 pi. Why it is happening? Just try to understand. This is a sphere. How the sphere is formed? You just imagine one orange and take one slice of orange. Okay, now keep it vertical. So how it will look like? So this is basically the vertical slice. Okay, now once you have one vertical slice, and then you add all the vertical slice in this format, then what it will be? This angle will represent phi angle, which will be from 0 to pi. See, this is from here to here, 0 to pi. Now this angle is the theta, okay, which is basically angle with x-axis. Angle with x-axis, that will be from 0 to 2 pi, making the complete circle. This is the concept of the spherical coordinate system. Okay, keep in your mind. Now from here, what is your r? So basically r is equals to xi cap plus yj cap plus zk cap. You replace the values. So r in terms of, because of that, earlier we were using phi and v. Here the parameters are earlier we were using u and v. Okay, see, here we are using u and v as a parameter, here phi and theta as a parameter. So we'll convert, everything will be in the phi and theta. So it will be a sine phi cos theta I cap, okay, plus a sine phi sine theta in j cap, and this is a sine phi k cap. Now you have to find out the derivatives of that. So derivative of r with respect to phi, so that is going to be a cos of phi. So derivative of sine phi is cos phi cos theta, as it is I cap. This is a, this is going to be a cos phi, okay, and again it is sine theta j cap, and this is going to be minus of a sine phi. Wait, it is cos of phi, then it is going to be sine phi minus a. Wait, I think there is a mistake. Why I am writing cos phi here? Yes, it's not sine phi, it will be cos phi, because here it is sine phi, and here it will be cos phi. Yes, so that's why it will be minus of sine phi. Yeah. So it is a minus of, okay, now it is not sine phi, it is cos phi, and it is sine phi k cap. Okay, see, it is something related to the polar coordinate system again. So sine phi, and this is cos in the terms of z. Here x, in x it is cos theta, in y it is sine theta. Here in x, y, sine theta, in z it will be cos phi, sine phi and cos phi. Okay, now derivative with respect to theta, and that is going to be minus of a sine phi, as it is, because it is cos theta, then it is minus of sine theta I cap. This is sine theta, then it will be cos theta, then directly a sine phi, and it will be cos theta j cap. Because of that it is phi, there is no theta, so it will be 0 k cap. Now what to do? You take the cross product of this, okay, r phi cross r theta. So it is going to be I cap, j cap, k cap. So whatever your answer, this is a cos of phi cos theta. Okay, next it is a cos phi sin theta. So it is a cos phi sin theta. Next is minus a sin phi. Here it is 0, and it is a sin phi cos theta, and it is minus a sin phi sin theta. Once you will solve, you will get a square sin square phi cos theta I cap plus a square sin square phi sin theta j cap plus a square sin phi cos phi k cap. How to solve? It's very easy. When you will multiply this to this, once you will multiply, see, it is a square sin square phi and cos phi. Okay, then you take this one, this will be 0, this is minus plus, again that minus will be a square. Okay, this is going to be, this is going to be a square. Here it is sin phi will be minus of this, like sin square of phi, and it is sin theta, and this is, there is no theta term, so it will be as it is. Now when you will multiply like this, this is a square sin phi cos phi, and this cos square theta will be there. Okay, and then once you will take sine square cos square theta common, that will be the same. Okay, I think here this one a square, this will be cos phi sin phi cos square theta, and here sin square theta, that will be 1, cos square sin square theta will be 1. So the final answer will be this. Once you have this is final answer, now you have to find out r phi cross r theta and its mod. How to find out the modulus? So modulus is basically the magnitude. So magnitude is basically the square of this, so it is basically a power 4 sine power 4 phi cos square theta, this square of this term. Now the square of this term plus this is a power 4 sine 4 phi, okay, and this is going to be sine square theta plus it is a power 4 sine square phi and it is cos square phi. Okay, so from here I can take common. Okay, cos square theta sin square theta take common, that will be 1. So the again it is a power 4 sine power 4 phi plus, okay, it's going to be 1 and it is a power 4 sine square phi cos square phi, because this and this term get common. Okay, then it will be a power 4 outside, this is sine square phi, okay, into again from here I can take sine square phi common plus cos square phi common, that is again going to be 1, and this will be a square sine phi. So from here now it is a square sine phi in this magnitude. So what is our like formula for the triple integral, so the double integral? That is going to be double integral of ds. This is the area, so the double integral modulus of r phi cross r theta d phi d theta, that is going to be double integral. And what is the value? That value is a square, this is a square sine phi, and this is d phi and d theta. Once you will solve this, now theta is from 0 to 2 pi and phi is from, wait, first limit will be from of phi, so phi is from 0 to pi, okay, 0 to pi, and theta is from 0 to 2 pi. When you will solve this, you will get like this. Because of that it is sine phi, so it is 0 to pi, it is 0 to 2 pi as it is, a square outside sine phi d phi, that will be 2, okay, so cos phi, and it is from 0 to pi, it is d theta, so it is a square into 2 pi minus 0. So cos pi is 1, cos 0 is 1, so 1 plus 1 will be 2, so whole answer will be 4 pi a square. So this is the answer for this question. This is how you can find out the surface area. Okay, now next come to the point that is called Gauss divergence theorem. So in the Gauss divergence theorem, how to solve the problem? So the Gauss divergence theorem, which is related to the triple integral and it's basically the triple integral and the double integral. So this is the relation between surface integral and the triple integral, or you can say the volume of the triple integral. This is how we can solve. Okay, next come to the problem. Wait. The formula, basically you have to find out the divergence of this. So this surface integral is equals to the divergence of this and the triple integral of. Let's take one example and solve this. How to solve this thing? This is the statement. It's very important. Let T be the closed bounded region in the R3 and the boundary surface is S. Let F be the vector field with the continuous partial derivative, because in this we need the partial derivative, so the partial derivative should exist in that case. Let's take the example. So the example is evaluate the surface integral. Okay, this is the surface integral S with x cube dy dz plus x square y dz dx plus x square dz dx dy. It's very difficult to solve using the previous concept. In that you have to find out the r, then ru, rv and all. Okay, this is x square plus y square is equals to a square, and here z is basically b. This is a cylinder which is given to you. Okay, so it's a cylindrical region. So in this case we will apply the Gauss divergence theorem. So using Gauss divergence theorem, GDT. Okay, so using Gauss divergence theorem, what you have to identify first, what is your f? So f is nothing but the coefficient of this will be I, so x cube I cap plus x square y. Okay, this is j cap and this is x square z, which is nothing but your k cap. Now what to do? What is the formula? So this double integral f n cap ds of s is equals to the triple integral. Okay, and Gauss divergence theorem is basically the divergence of this, and which is equals to the volume. So your target is to get the divergence of this. It's very easy to find out the divergence. So delta dot f, it's very easy. Okay, how to find out the divergence? So that is basically dou by dou x of x cube plus dou by dou y of x square into y, and then dou by dou z of x square into z, and that is basically 3x square plus x square plus x square, that is basically 5x square. So it is nothing but the triple integral of 5x square, and this is dx dy dz. Now here it is given as a circle, or the base is the circle, is the cylindrical coordinate. So here you have to convert this into polar coordinate system, or what you can say is the cylindrical coordinate system. So it's very easy to convert. So how to convert? See, so this is basically the triple integral 5x square dv was given. So let's take x is equals to r cos theta. So what is your x square? That will be r square cos square theta. And one more thing, dv will be r dr d theta and dz. This is cylindrical coordinate system. Okay, so here, because it is x square plus y square is equals to a square given, and z is given from 0 to b. Okay, so this is the limit of z will be from 0 to b. Theta is from 0 to 2 pi, because whole sphere is there, sorry, whole circle is there like this. This is the cylinder. Okay, so this length is given as b, which is from 0 to b. Okay, this is your z length, and this is given length a. So this is basically x square plus y square is equals to a square. Okay, and r is basically from 0 to a, and this is your 5x square, that is basically r square cos square theta, and dv is nothing but r dr d theta and dz. Now you simplify this. This is from 0 to b, 0 to 2 pi, and this is from 0 to a. So 5 outside, this is r cube cos square theta dr d theta dz. Okay, first you integrate with respect to r. Okay, so it is 2 pi. When I will integrate r cube, that is r power 4 by 4, 0 to a, this is cos square theta d theta and dz. So how to handle the cos square theta we all know. So this is 5 by 4 and a power 4, this is 0 to b, and this is 0 to 2 pi. So cos square theta is nothing but 1 plus 2 cos, sorry, 1 plus cos 2 theta upon 2. Okay, and this is d theta and dz. Once you will solve this whole integral, how to solve that? Okay, let me simplify complete. So from here, from here it is basically 5 by 4 a power 4. Okay, because there is no z term, I can directly write b minus 0. I can directly write with respect to z first, or okay, don't get confused, remain this 0 to b. Now the integration of 1 by 2 is nothing but 1 by 2 theta, plus integration of cos theta is nothing but sine 2 theta upon 2, and this 2 will be like 4. Okay, so this is from 0 to 2 pi and dz. Now it is 5 by 4 a power 4, 0 to b. This is 1 by 2 into 2 pi. Okay, plus this is sine 4 pi upon 4, which is going to be 0 dz, and this will be basically 5 by 4 a power 4 into this 2 and 2 get cancelled, so this is your pi and this is your b. So the final answer will be 5 by 4 because this is going to be 0, so pi a power 4 into b. So this is your final answer. This is how you can solve using the using the Gauss divergence theorem this question. Okay, this can be solved using the surface integral, but the problem is that to convert into the r and then finding the ru, rv, that will be very difficult. So that's why we are using this Gauss divergence theorem. Okay, now next come to this question, evaluate the surface integral. Again we will use this surface integral to here. This is your s 7x I cap minus z k cap n cap dA. So we will convert this into our triple integral. So first of all, your target is to identify f. So what is your f? That is x I cap 7x I cap minus z k cap. Okay, from here you find out its divergence. So what is the divergence of this? So it is basically a partial derivative of 7x with respect to x. Okay, then 0, then partial derivative of minus z with respect to z, that is going to be 7 minus 1, and that is basically 6. So what is the formula? So this will equals to the formula triple integral over t. Okay, triple integral over t, and that is basically 6 dv. Okay, so we put 6 outside, and this is one sphere is given. Okay, so triple integral, this is your d v is given. Okay, so this is x square plus y square plus z square is equals to 4 is given. Now there are two methods to solve this. Method 1, direct method. So what is that method? In this case, method 1, what is the radius? The radius is 2 for this surface, and we all know what is the surface, what is the area, volume of the sphere, that is 4 by 3 pi r cube. Okay, then it will be going to 60, it will be 64 pi. But I will not suggest to use this in your exams. What to do? Once you are receiving this, getting this triple integral dv, okay, t and dv, this is x square plus y square plus z square is equals to 4. Now what to do? Convert into spherical coordinate system using the spherical coordinate system. So what is the spherical coordinate system? I think previously we have used that in the previous question. X is equals to r, this is your sine phi cos theta. Y is equals to r sine phi sine theta. Okay, and z is equals to r cos phi. What is your dv? dv will be r square sine phi dr d phi and d theta. Okay, where phi will be from, phi is angle 0 to 2 pi, this one vertical angle, this is 0 to pi, and theta will be angle with x axis, it is 0 to 2 pi. Okay, this is how if you will apply. So this is r is equals to from 0 to 2. Okay, this is your phi angle. So your theta angle will be from 0 to 2 pi, and your phi angle will be from 0 to pi. This is 6 outside, and dr will be, this will be r square sine phi. Okay, sine phi d phi, or you can write down dr d theta and d phi. When you will solve this complete integral, then also you will get 64 pi. Okay, this is using spherical coordinate system. It's very, very important to understand this thing. Now the question can be asked in the form of like this. Let's say this is the question. Okay, let's solve one more question, and then we'll see one different type of question. So let's take this question, x square plus y cube. Okay, x square plus y cube. In this case, this is f. What is, first of all, identify the f. So this is f is equals to x cube I cap plus y cube j cap and z cube k cap. Okay, then find out its divergence. So what is the divergence of this? Is the dou by dou x of x cube plus dou by dou y of y cube, dou by dou z of z cube is going to be 3x square plus 3y square plus 3z square. Okay, so this is what, let's say I have this x square, y square, and this. Now z is greater than of 0. So yeah, so in this case I have this one. It's very easy to calculate. Put the divergence. What's the formula? So formula t, so it is basically 3 outside. This is x square plus y square plus z square, and this is dv. And I have this problem that surface is given that x square plus y square plus z square is equals to 9. It means radius is equals to 3, z is greater than equals to 0. Now it means it is a hemisphere. It is not full sphere. The full sphere is like this. Okay, so it is a hemisphere. So this was the full sphere in which my phi theta will be from 0 to 2 pi. Okay, phi will be from 0 to pi. But once if it is a hemisphere, it means this portion is not there. Now if this portion is not there, then what is the meaning of this? Now it is something hemisphere. So hemisphere, it means now phi is from 0 to pi. Okay, pi by 2. Now phi is running from 0 to pi by 2, not from 0 to pi. So in this case phi will be from 0 to pi. So this will be your hemisphere. Okay, it is very, very important. This is called hemisphere. Okay, so in this hemisphere, using the spherical coordinate system, so phi is going to be 0 to pi by 2. Theta will be same because it will be complete sphere. Okay, and r is going to be 0 to 3. The radius is from 0 to 3. This is your r, and this x square plus y square z square, that is basically r square. This is r square. Dv is basically r square into sine phi, and this is dr. Okay, dr d phi and dr d theta and d phi. Then once you will solve this integral, it's very easy. It will be 486 pi by 5, and this is the solution. But the main concept was this. This was the important concept. Keep in your mind whenever you are solving this question. Next, the question can be asked in the form of find the surface integral using Gauss divergence theorem, where f is this. This is your f, that is x square I cap plus z square k cap 0 j cap. Okay, surface is the box. Mod of x is less than equals to 1, mod of y is less than equals to 3. So mod of z is less than equals to 2 means it is a cuboid. Okay, also verify the Gauss divergence theorem. It is very, very important. Now it is saying that verify the Gauss divergence theorem. It means you have to prove that Gauss divergence theorem. You have to prove that this f dot n cap ds is equals to over this surface is equals to the triple integral of this t for this Gauss divergence. The divergence of this, these both are equal. So this is your left hand side portion, this is right hand side, this is RHS and this is LHS. Now here first I will give you the solution using RHS. Okay, let's solve first RHS. What will be the answer? So first of all, find out the divergence of f. So what will be the divergence of f? It's very easy. Divergence of f will be 2x plus 2z. Okay, then you apply the triple integral, that is basically 2x plus 2z over dv, that is going to be 2. It's a triple integral and it is basically x plus z, and it is dx dy dz. Now the limit of x, mod of x, it means it is basically okay, so what do you mean by the mod of this? So the mod of this is going to be like this, minus 1 to 1. Okay, this is minus 3 to 3 and this is minus 2 to 2. Okay, so this is x is going to be minus 1 to 1, y is going to be minus 3 to 3, and z is going to be minus 2 to 2. When you will apply to this, what will be the answer? The answer will be 0. Okay, this is the solution. It's very easy. Okay, let me solve complete. It's very easy. What's the solution? So the solution is basically minus 2 to 2, minus 3 to 3, and minus 1 to 1, x plus z dx dy dz. First you integrate with respect to x. So minus 2 to 2, minus 3 to 3. This is x square by 2 plus z into x minus 1 to 1 dy dz. When you will solve this, it is basically, okay, 2 is also there, yeah, 2 is also there, then it is minus 2 to 2 minus 3 to 3. When you will apply this, this is going to be 1 by 2, okay, 1 by 2 plus z minus and minus, it is 1 by 2 minus plus z, I think, yeah, it will be plus z dy dz. So this will get cancelled, so twice of minus 2 to 2 minus 3 to 3, and now it becomes 2z dy dz. Okay, when you will solve this, this is 4 minus 2 to 2, this is z into y is from minus 3 to 3, now this is dz. So it is going to be 4 minus 2 to 2 z, it is 3 plus 3, and then it is z. So when you will solve this, it is basically 4 into 4 into 9, so 36, sorry, not 9, 6, 24. Okay, now it is odd basically. Okay, of course it is z square by 2, and minus 2 to 2, when it will comes, it will be 0, because this is odd function, so it will be 0. Okay, again here it is also, it is odd, then it will be 0. That is the concept. Now you have to solve the right hand side and left hand side, and you have to show that it is equals to 0. Now this left hand side will be solved using the surface integral formula. So how this formula will look like? So this formula will look like this. This will be the formula. So double integral f in terms of uv, then ru cross rv du dv. But this will be for all the faces, all 6 faces. Okay, because this is cube, keep in your mind. Now let's begin with this problem. So this is triple integral f dot n cap ds. Okay, the formula is double integral f uv, okay, then ru cross rv, this is du dv. Now let's begin with phase 1, but before going to that, you have to consider x is equals to u, y is equals to v. Okay, and what will be the z here? So in this case, yeah, the problem is this, it's very important, because your x is equals to plus minus 1, y is equals to plus minus 3, z is equals to plus minus 2. So it's a cube. Okay, it's a cube or cuboid. Let's say it is a cuboid. Then take phase 1. So first of all, phase 1. Okay, first phase 1 means x is equals to u, y is equals to v, x is equals to 1. Phase 1 means x is equals to 1, which is created by this 1. So if x is 1, then your y is equals to u. Okay, you can't consider here. So here you have to consider y is equals to u, then and z is equals to v. So like what we'll do, so like simply like these are the like parameter which we are going to putting in this formula. Okay, so okay, first of all, your f is basically x square I cap and z square j cap. You convert this into uv. Because of that, x is fixed, so it is f is equals to 1 I cap plus z is equals to, this will be v square k cap. Okay, then once I will find out this, I will find out the position vector. Now the position vector is xi cap plus yj cap plus zk cap. As I fix the values, so here x is equals to 1, y is equals to u, and z is equals to v. I will put these values here. So my r in terms of uv will be I cap plus this will be uj cap, and this will be v k cap. Okay, now you have to find out the partial derivative with respect to u of this r, that is going to be 0 I cap plus 1 j cap plus 0 k cap. Okay, and this is rv, and this is again 0 I cap plus 0 j cap and then 1 k cap. Well, okay, so this is basically j cap and k cap, and the cross product of j cap k cap, that will be ru cross rv, that is going to be j cap cross k cap. Once you will solve this, you will get from here, this is I cap. Okay, this is I cap because j cross k cap is I cap, or you can solve using the determinant form. The thing is that it is basically called normal vector. Okay, so this is called normal vector, which is normal to the face of this. Okay, let's say this is my face, so from here this is the normal vector, so it will be I cap. If I will take let's say minus of like 1, okay, so I have, let's say this is x minus 1, so this will be downward direction of this, so it will be basically minus of I cap. Okay, now you have to apply into, like, put into this formula, and that is basically going to be like this. So the formula is double integral of f uv, and then it is ru cross rv. This is called a normal vector, and sometime usually we are representing with this n, and this is your du dv. Okay, so when you will apply this formula here, and here your u is basically y, so y limit is from minus 3 to 3, and v is z, so it is from minus 2 to 2, and this is going to be f. So f is basically we converted, that is x square, and this z square, that is I cap, plus z square is basically v square, so it is v square k cap. Okay, so this is v square k cap into I cap du dv. Once we will solve this, because of that there is only I component, this k dot I will be 0, so it is minus 2 to 2, this is minus 3 to 3, and this will be going to be 1 du dv, and this is basically 6 and 4, 6 into 4 will be 24. This is how we got the solution for the phase 1. Now we have to solve for the phase 2 in the similar manner, but the change will only be, my x is going to be minus 1, and y is going to be u, z is going to be v. Similarly for phase 3. Okay, once you will solve for, okay, in this case it will be minus 24, because it is just opposite of that, because the problem is with this only, whenever you will solve this phase, you will get the negative normal vector. Once you will get the negative normal vector, all the remaining things will be same. Okay, so if you are phase 3, and phase 3 will be basically y is equals to 1, you can take, okay, sorry, y is equals to 3, and then your x is equals to u, and your z will be v. So in that case you will get some different value. Okay, when you will get some different value, you can put that value. Let's take, I have already calculated, that is what, let's take, that is 48. So if it is 48, if I will take phase 4, then in the phase 4, let's take y is equals to minus 3, and again x is equals to u, z is equals to v, this is minus 48. Okay, so and in the similar form, let's take phase 5th, it means phase 5th of the your cube. In that case, let's take z is equals to here z limit is from minus 2 to 2, so it is minus 2 or plus 2. Okay, and take the x as u, y as v. In that case you will get some different values. Okay, so in that case, let's say you are getting some 0. Okay, so okay, here you are getting 0, and this is also 0, here you are getting 48. So again, 6th phase of the cuboid, in that case let's take z is equals to minus 2, here you will get minus 48. Once you will add all these phases, all the surface integral of the phases, you will get the same answer. It means your Gauss divergence theorems is verified. Okay, so once the question is that verify the Gauss divergence theorem, you have to solve right hand side as well as left hand side. You have to solve using your concept of the surface integral as well as the divergence, basically the Gauss divergence theorem. Okay, this was all about the Gauss divergence theorem. Now let's move to the Stokes curl theorem. So it is what all about the Stokes theorem, and in the Stokes theorem, it's a statement is basically whenever you have a function, and of course the surface should be the piecewise smooth surface in the oriented surface with the boundary curve C, and your function is a f vector is a force vector called let's say it's a like vector field, and with continuous partial derivative, because here also we are going to finding the curl. To find out the curl, there should be continuous partial derivative. Okay, partial derivative should exist, and that should be the continuous. In that case we can find out the Stokes curl theorem. Okay, so let's understand the concept using the questions. Okay, that's the important thing, how do we solve the questions, and it's very important. Okay, again there are two types of question. First one is find the basically like find the line integral using the Stokes theorem. It is the relation between like double integral and like line integral. Okay, so using this curl we will find it out. Two questions, again verify the Stokes theorem or apply the Stokes theorem. Once the question is apply the Stokes theorems, you simply apply the Stokes theorem, you apply this formula and you can solve. No need to go for the like LHS part. If it is like verify this is Stokes theorem, then you have to solve both the right hand side, left hand side using the line integral formula and using the double integral formula. Let's take one example and clarify this thing. Evaluate the Stokes theorem of f dot dr. So this is your question, f dot dr, where C is a circle. So the curve is given that is a circle, x square plus y square is equals to 4 and z is basically minus 3. It's a given curve, curve is given as a plane is given, z is equals to minus 3. And the orientation of this orientation is the direction is basically the counter clockwise direction. Okay, and this is your f given, f is equals to y I cap plus x z cube j cap minus z y cube k cap. Okay, let's begin with this. How to solve this or how to apply this curl theorem, Stokes curl theorem. So what is the formula? First of all, recall the formula. It's a double integral of the curl. Earlier in the Gauss divergence, we were finding the divergence. Here we will find out the curl. It's a simple difference between them. It's a n cap and ds. Okay, so it's equals to the line integral of f. It's basically r, or I can write dr. How to find out the curl? Okay, we have seen the previous concepts. The curl is nothing but determinant, that is I cap, j cap and k cap. Okay, del cross f. The coefficient of I cap is dou by dou x, dou by dou y, dou by dou z, and f is given as coefficient of y is y, coefficient of j is x z cube, and the coefficient of k is minus z y cube. Okay, so once you will write down this is your determinant. You solve this determinant. Okay, that is basically dou z by dou x minus dou y by dou y. Yeah, once you will multiply, that will be dou y by dou y. No, wait, it's basically x y. Yeah, so this is basically j cap, I cap, then it is dou by dou y, sorry, it is minus z y cube minus it is dou by dou z x z cube. Okay, then minus of j, you have to apply minus of j, that is basically dou by dou x minus z y cube. So it is y cube minus of dou by dou z of y. You have to simplify like solving the partial derivatives. So this is dou by dou x of x z cube minus dou by dou y of y. Okay, when you will solve all these partial derivative, so the answer will be I cap. Once you will solve, this is minus z 3y square minus 3x z square. Because of that, it is partial derivative with respect to x, there is no x term, it will be 0. So this is 0 plus k cap, and this will be the partial derivative with respect to x, so it is z cube minus 1. Okay, once we will get this, so our like derivative will be like this. So now you have to apply this curl value to this formula. Once you have this curl, and now you have to find out n cap dot ds. N cap dot ds is basically the normal vector with ds. N cap is your normal vector. So what is the value of n cap and ds? So n cap ds is nothing but n cap is basically normal, and which we are getting using the like tangent vectors. Okay, so the tangent vectors are your ru and rv. So that's the concept. So this is the partial derivative of ru. Okay, partial derivative of r with respect to u and with respect to v, and ds is the like area element, that is your du dv. Then you have to simplify this. So here the given like curve is basically a circle. So that is what x square plus y square is equals to it's a 4. Yeah, x square plus y square is equals to 4. In that case, I will simply replace x as u y as v is a transformation, so uv transformation we are converting into uv. Now replace with this, so it is basically u square plus v square is equals to 4. And here what will be your r? So basically r is a position vector, that is xi cap plus yj cap and zk cap. Okay, that's zk cap. Now from here we are going to replace r basically converting it into the parametric form, that is r and uv form. So that is what ui cap plus vj cap, and from here z is given as a specific value -3, then you put the value of z as -3. Okay, z is given as -3 -3 k. Now finding out the partial derivative of r with respect to u, that is going to be only I, and the partial derivative of v with r with respect to v, that is going to be j. Now again ru cross rv. Okay, ru cross rv is nothing but I cross j, so I cross j is nothing but k cap. Now this is your normal vector. You apply this normal vector to here and then simplify this double integral. So this is the double integral. So the value of n cap ds, so value of n cap ds is nothing but k cap into du dv. And again the curl is nothing but this one, this is your curl. Okay, minus z 3y square. Now you again here you have to also apply the values of x, y, z in terms of uv. So once you will apply this term, that will be -3. Okay, -3y. Okay, because it is y square, then I will write it as v square minus it will be 3u minus 3 square. Okay, at the place of z you put -3. This is I cap, then 0 j cap, and it is plus this is -3 square minus 1 k cap. You multiply this whole thing with n cap dot ds. N cap dot ds is nothing but k cap du dv. Because of that it is only k component is there, so I dot k will be 0, j dot k will be 0, k dot k will be 1. So it is double integral of 9, that's 3 square. Okay, sorry, it's 3 cube, so 3 cube is basically 27, so it is 27 minus 1 du dv, and it is 26, and the area of a circle. Again it is x u square plus v square is equals to 1. Convert into the polar coordinate system. So here r will be from 0 to 1. Theta is a whole circle, so that's why theta is 0 to 2 pi, and this is going to be dx dy is r dr d theta. Once you will solve this, you will get solution as minus 112 pi. Okay, this is the solution for this when you will solve this after multiplying with this 26. Okay, wait, okay, this is minus, so that's why it is 28 not 26. This is minus 27 minus 1, that will be minus 28. If it is minus 28, and then if you will multiply, you will get minus 112 pi. That will be the line integral value for this particular case using the Stokes theorem. Now the question can be like this: verify this Stokes theorem, then you have to apply the line integral formula, you have to solve, you have to prove this left hand side as well as right hand side. Okay, this is the basic concept. So here what we are doing, line integral we are approximating using the area. Okay, let's say I have this curve, this is, okay, let's say in the previous question it was a circle. In the line integral, I will use the parametric form of the circle, that is x is equals to cos of t and y is equals to sin of t, which is satisfying my equation x square plus y square is equals to 1, or you can take some r square. So in that case, you are going line by line. Okay, you are going line by line, you are going boundary, or you are going boundary by boundary. But here if you will find out the curl, it means you got the rotational thing of that, and the direction is very, very important. So in that case, you can approximate using the area. You can find out the line integral using the area of the finding the curl and its direction, or by, of course, by taking the normal vector, that is n cap dot ds. Okay, now let's take one more example on this, that is again very, very important. And in this case, let's say your f is given as y I cap plus z j cap and x k cap. Okay, in this case this is your f. So again, to apply the curl theorem, this is basically double integral, so finding the curl of f n cap, and this is your ds. So finding the curl, so del cross f vector, that is your I cap j cap and k cap. Okay, dou by dou x, dou by dou y, dou by dou z, and this is your y, z and x. Once you will solve this curve, you will get minus I cap, minus j cap, minus k cap. It's nothing but just finding the determinant. Once you will get the determinant, you have to put this value here, or before going like calculating that, we have to finding out its normal vector n cap dot ds. So what do you mean by the n cap? In that case, you have to find out the r vector, ru and rv. Okay, so basically it's a surface integral, and it is minus I cap, minus j cap, minus k cap, and this n cap is going to be ru vector and rv vector. It's cross product, and this is du dv. Now we have to find out the value of ru and rv. Again, r is nothing but the position vector xi cap plus yj cap plus zk cap, and here we will replace x with u, y with v, and of course the z will be the relation between them, and z is given as a paraboloid. Okay, so here the paraboloid is given 1 minus x square plus y square. So your z is going to be 1 minus u square minus v square, where z is greater than equals to 0. It's this paraboloid is starting, this paraboloid is towards, the orientation is towards in the positive z direction only, upward direction you can say. So in this case, I will simply find out the values of the r vector. So here r is going to be xi cap plus yj cap, zk cap. Put the values in terms of ruv. So it is ui cap plus vj cap, and z is nothing but 1 minus u square minus v square k cap. Okay, then you put ru. U means what? Partial derivative of r with respect to u. So that is going to be 1 I cap, 0 j cap, minus 2 u k cap. And similarly rv is nothing but 0 I cap plus 1 j cap. Okay, partial derivative of v with respect to v is 1, and this is minus 2 v k cap. Now you have to simply take the cross product of ru and rv. So this is ru cross rv. Take the cross product I cap, j cap, k cap, and the derivative dou by dou x, dou by dou y, dou by dou z. It's going to be 1. Okay, so okay, wait, we are not finding the curl, we are finding the cross product of ru and rv. So the coefficient of I is 1, coefficient of j is 0, coefficient of k is minus 2u. Similarly here the coefficient of I is 0, coefficient of j is 1, and this is minus 2v. Once you will solve this, you will get this as 2u I cap plus 2v j cap and plus k cap. Now what we have to do? We have to simple plug out these values here. This is your minus I cap, minus j cap, minus k cap, and this is 2u 2v into 2u I cap plus 2v j cap plus 2 plus k cap, and this is du dv. The thing is that there is no x, y, z or the variable in the f. If it was there, then we have to put that value. Okay, then keep in your mind, you have to convert whole integral in uv form. Once you will convert this integral into uv form, let's copy this and solve this whole integral. Now how to solve this whole integral? So this is your whole integral. You just multiply these things, the double integral. Okay, when you will multiply, this is going to be 2u plus 2v plus 1, and minus will be common. Everything will be minus, and this is du dv. Now what is your reason? The reason is given as a paraboloid. Okay, if it is a paraboloid, z is equals to 1 minus x square plus y square, and it was basically z is equals to 1 minus u square plus v square, because x was u and y was v. From here, if I will take z is equals to 0, because z is greater than equals to 0, I can take z 0 for the initial point. Then it is 0 is equals to 1 minus u square plus v square. Then it is basically u square plus v square is equals to 1. So now it is a circle. Just convert into the polar form. So basically u is equals to r cos theta. Okay, and v is equals to r sin theta. So simply you apply here. R is going to be 0 to 1, theta is going to be 0 to 2, u is cos theta, so it will be 2r cos theta, and it is 2r sin theta plus 1, and du dv will be r dr d theta. Once you will solve this, you can easily find out this solution, and that solution is going to be minus pi. It is just a bit calculation is there. I will not waste time in the calculation. So this, when you will solve this integral, you will get this answer as pi. Now this was the question. Just the question was, read the question. Here it was, verify the Stokes theorem. Now here you have to verify the Stokes theorem. Here we have solved this part. Now we have to solve this part, f dot dr. How can we find out this solution using the line integral part? So in that case, what you have to do, you have to convert your line integral into this. See how you will solve this question into the line integral form. So this is your f vector dot r dash dt. So this is nothing but dr dt. Okay, so this is basically I can simply write it as dr, and dr is a parametric form. So in that case, you have to convert z is equals to 1 minus x square plus y square, because this is the reason is given. Here you take r is equals to 1 because x square plus y square is equals to 1. This is the circle, radius is 1. The parameter that you can choose, that is x is equals to r cos t, y is equals to r sin t. When you will apply this, so r vector, the position vector is going to be xi cap plus yj cap and zk cap. So here r is basically r in terms of parametric form. So that is going to be, because okay, one more thing, here z is equals to 0. I'm going to put z is equals to 0 because I will take this whole thing into the 2D. Okay, this is z0. So here it will be xi cap plus yj cap. Once if it is there, then r of t is going to be cos of t I cap plus sin of t j cap. Then you find out its derivative, that is dr, that is the derivative of sin t, sorry, cos t is minus sin t I cap. Okay, sin t dt will be there, and it is cos of t dt will be there. Now here you simply apply these values here and put f in terms of t also. Once you will put in terms of t, again you will get the same answer as minus pi. So this is what here, first part and the second part both are equal. This is the question which is something, verify the Stokes theorem. Okay, let's take one more question in which the same question is asked, verify the Stokes theorem. If you want to verify the Stokes theorem in this case also, so you have to solve both the portion like this. This is f dot dr, which is equals to the curl of this is n cap ds. This both should be equal. Let's start with the left hand side. Okay, means the line integral portion. This is f dot dr. So okay, first what is your f? F is given as minus y cube I cap plus x cube j cap. Okay, and the reason is given as a paraboloid. As the paraboloid is x square plus y square less than equals to 1 and z is equals to 0. So from here, if I'm solving the line integral, I will convert this into, because the region is circular region, okay, paraboloid region, the like cross section of the paraboloid will be a circle. So in that case, again you have to convert. I told you, whenever you have a circular kind of thing, you simply convert that into parametric form, and that parametric form should be x is equals to cos of t and y is equals to sin of t. Okay, so in that case, when I will apply to this, so this will be basically dx is basically minus sin t dt, and the derivative of y, that will be cos of t dt. So this is cos of t dt. And now here f dot dr, what is your r? R is going to be xi cap plus yj cap, because it is in 2D only. Or if I will take z is 0 already given, then I will not go to that. So this is dr is dx I cap plus dy j cap. Once when you will solve this f dot dr, that is nothing but your f is minus y cube dx integration plus x cube d y. Okay, now along this curve C or this paraboloid S. Okay, so this is what you replace the values, that is minus of y cube. Y cube is basically minus sine cube t. Okay, dx is sine t dt. Okay, plus x cube is cos cube t, and dy is basically cos t dt. Okay, this is basically sine power plus sine power 4t and cos power 4t. Then you have to replace the formulas and then you will get it is 3 pi by 2 as answer. But this answer is using this line integral concept. Okay, but using the curl, Stokes curl theorem, you can also find it, because the question is verify the Stokes theorem. Okay, so the verify the Stokes theorem is means you have to solve both the portions. Now let's begin with this part. That part is basically double integral. So, okay, del cross f, this is your n cap ds. So n cap ds. Now here again, first of all you have to find out the curl part. Okay, so what is your f? F is given as minus of y cube. Okay, minus of y cube I cap plus x cube j cap, because z is given, z is not there, so I will simply write down as z k cap. Then the curl will be I cap j cap k cap dou by dou x dou by dou y dou by dou z, finding out the partial derivatives and solving the determinant, that is minus y cube x square, and this is going to be 0. Okay, so simple, this will be I and it will be 0, x square will be 0, j will be 0, only k coefficient will be there, that is 3. Okay, so wait, that is going to be 3x square plus y square. Let me check. This is k cube, and once I will solve this, this is going to be dou by dou x of x square, and this is going to be minus of dou of minus y square by dou y, and this is your k square, which is 2x, and this is plus 2y. 2x 2y. Yes, now what is your n cap ds? So you have to find out the n cap. N cap means your ru cross r vector. So this is your ru cross rv. In this case, what will be your r x I cap plus yj cap plus zk cap. Okay, similarly this question, same previous question which we have solved completely here. So from here you have to convert, finding out the r, putting the values, putting the relations, put the x is equals to u, y is equals to v. Because of that, here z was given as a paraboloid, where z is given as 0. Put the values, you will get the same answer. So again, after putting this value, after solving this, you will get this 3 pi by 2, just nothing but putting the values and multiply, and it's a double integral. So this is how we can verify that Stokes theorem. Okay, this is one more question is there which you can easily solve. I will give you the explanation about this question. In this question, z is given as 0. It means it is a triangle. Okay, okay, here the coordinates are given in the 3D, that is 0 comma 0 comma 0, it is 1 comma 0 comma 0, and it is 1 comma 1 comma 0. So 3 coordinates are given. Okay, I will draw the 3D axis. So let's say the 3D axis is like this. This is z axis. Wait, yeah, let's say this is z axis, this is y axis, and this is x axis. Okay, this is x, y, and z. So z is 0, it means this complete will be in xy plane. If it is xy plane, it is telling 1 comma 0. So what do you mean by 1 comma 0? Means x1 y0, and 1 comma 1 means this is 1 comma 1. So basically this is the triangle. So from here, if I will convert into this is your x, this is your y, this is 1 comma 1, and this is 1 comma 0. So this is basically the triangle. So like this, here this is the triangle. Okay, in this case this is in xy plane. Again, if it is in xy plane, it's very easy to apply the Stokes theorem. So what is the Stokes theorem? Double integral curl of f, finding out its normal ds, and of course its normal will be k cap. Why? Because it is in 2D plane. If it is in 2D plane, so the normal will be the z axis, that is your k cap. So replace this with k cap and find out this curl. You can easily solve this question. Okay, so this was all about this vector calculus unit, in which we have started from the gradient and we came to the Stokes theorem, Gauss divergence theorem, and this Green's theorem. These 3 theorems are the very important. Okay, thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.